Hello! The goal of this video is to present you how to visualize the hyperparameters of a model when the involved predictor has more than two of them. We can already encounter one example of such cases in the lecture notes where we used a randomized search for finding the best hyperparameters of a histogram gradient boosting classifier that was trained on top of the adult census dataset. And in that case, we only used a few iterations, but in practice, you would have to run a large number of iterations to try different combinations of hyperparameters. In this case, we will load a pre-computed dataset containing the results of running the model and validating it with 200 iterations. And we can take a look at the head of this dataset and realize that we are tuning 5 different hyperparameters, and all of them are preceded by this double underscore, which comes from the fact that we used a pipeline. So one thing that may come to our minds is to define this function that will help us remove the prefixes of the hyperparameters, and then have a second look at the dataset with this cleaner version of the column names. And now we can really see which hyperparameters we are tuning. For instance, the maximal number of beans, the maximal number of leaves per each node. In this dataset, you can also see the score for each one of the splits in the cross-validation. And also you can see the mean test score, the standard deviation, and this ranking position of how good or bad is in this ranking this particular combination of parameters. So we can think of possible ways to visualize these scores, and one of the possibilities is having this kind of scatter plot kind of heat map that will encode the mean test score in colors for each combination of learning rate and maximal number of leaves. And here we can notice that there is a band between 10 to the minus 2 and 10 to the 0 in learning rate, and they will lead us to the best possible scores. But the problem with this visualization is that it's a two-dimensional projection of a multi-dimensional hyperparameter space. So we don't really have control on how the other parameters influence or not these different points. So maybe we can think of a more clever way to visualize the results, and one option is to use the so-called parallel coordinate plot, which also encodes with colors the mean test score. But also you can click on any of the axes, and if you click and hold, you can select a range of scores, for instance here, and ask yourself which combination of hyperparameters will lead me to this bad score. But you can also click and drag the selection and ask yourself the same, like what are the combinations leading to a medium score. Or you can click on the edge of the selection and broaden it or shrink it and drag it. And if you click again on the selection, you can get rid of it. And maybe you can ask yourself the inverse problem, like what will happen if I select, for instance, this range of learning rate between 10 to the 0 and 10 to the minus 2, and it will always translate to a good score. But what happens if I also choose a small number of maximal beans? This will actually prevent our model to reach the highest scores. So by doing so, you can have an idea of how different the parameters interact between each other. So this is a really useful plot, and I hope it will be useful for you as well. Thanks for watching, and see you next time.